We'd like to integrate cosine x e to the 5x. If you haven't done this yet, please push pause and do it, and then come back and watch the solution. Let's go ahead and find the solution now. Integrate cosine x e to the 5x. Again, you can do this either way, where you take the f prime to be your trig function or the f prime to be your exponential. I think I'll take my f prime to be my trig function this time, and my g to be my exponential. Maybe you did it the other way. Maybe you put your f prime as your exponential and your g as your trig function. Try to see if you got the exact same answer that I got at the end. In fact, I may try to do this both ways once we get the answer. Antiderivative of cosine is positive sine of x. Derivative of e to the 5x is 5 times e to the 5x. Notice that's why I chose this way, because when I did an antiderivative, I was getting positive signs. I like dealing with positive signs instead of negative signs. And I like to deal with 5s instead of 1/5. But it's the same answer in the end, hopefully either way. Okay, f times g, that's going to be sine of x times e to the 5x minus integrate f times g prime. F is sine of x. G prime is 5 times e to the 5x. I still have a trig function times an exponential. We're going to, once again, utilize my f prime and my g. F prime in this case, let's make sure that these is all the same size. F prime, I'm going to set, since I set my trig function earlier as my f prime, I'm going to do that once again. So f prime is going to be sine of x. G is going to be 5e to the 5x. The antiderivative of sine is negative cosine. The derivative of g would be 25e to the 5x. That means this expression can be replaced with f times g. Now you got to be a little bit careful. I didn't distribute my minus sign in. Probably would have been easier to distribute my minus sign in. Let me do it that way and call that negative sine. And then the antiderivative of negative sine is positive cosine. That's a little bit easier to deal with. F times g is cosine, again, positive cosine of x multiplied times 5e to the 5x minus integrate f times g prime. Well, f is cosine of x. G prime is 25 times e to the 5x. 25 can be factored out, meaning outside of the integration. And notice the inside of the integration matches up again, cosine x e to the 5x once again. Let's make this be a little bit smaller so it all can fit on one line. What we're going to do is we are going to add 25 times the integration of cosine x e to the 5x with respect to x to both sides. I'll do that to the left. Once again, make sure everything's sized correctly. And then I'll also do that to the right. On the right, it'll cancel this integration out. When you add one integration plus 25 of the same integrations, you get a total of 26 integrations of cosine x e to the 5x is equal to sine x e to the 5x plus cosine 5 e to the 5x. I'm going to make that a little bit nicer looking. I'll put the 5 in front there. This is what we end up having. The last step is to recognize that, well, the two last steps, I'm sorry. We have two last steps. First step to solve this is divide both sides by 26. If you divide the left-hand side by 26, you just get one of your integrations. If I'm dividing by 26 on the right, I can do 26 times the whole thing, or 1 over 26 times both pieces. If I distribute it in, meaning I divide each piece by 26, I get 1 over 26 sine x e to the 5x plus 5 over 26 cosine x e to the 5x. And then we add a plus c at the very end. Now, I said that this shouldn't be any different if you use the other f prime and g. If we went back up to our original problem, and what if I had set e to the 5x as my f prime and cosine as my g? Let's go through this very quickly to see what happens. Antiderivative of e to the 5x is 1/5 e to the 5x. G prime, derivative of cosine of x, is negative sine of x. That means that integration would have been f times g, 1/5 e to the 5x times cosine x minus integrate f times g prime. That's 1/5 e to the 5x times negative sine of x. Instead of writing negative sine, that negative sign is going to make that minus be a plus in front. Now I would do an iteration of this second integral. I do another f prime, and I'm going to utilize 1/5 e to the 5x as my f prime. My g, I'm going to utilize as sine of x. That means the antiderivative of 1/5, or an antiderivative of 1/5 e to the 5x would be 1 over 25 e to the 5x. The derivative of g is a positive cosine. This integration therefore becomes the same thing, but we were going to replace this integration piece with f times g minus integrate f times g prime. Again, we get an e to the 5x cosine x. I'm going to pull out the 1 over 25 and put that as a coefficient of the integral. Again, cosine x e to the 5x was the thing we were trying to integrate. Let's make that the right size so we can all fit it on one line. That thing is equal to this mess. In order to figure out how to do this, I would have to add 1/25 times this integration to both sides. So I'd add 1/25 times the integration to the left-hand side, and then I would add 1/25 times the integration to the right-hand side. That'll cancel out the integration on the right-hand side. And on the left-hand side, be careful when you integrate, or when you add, excuse me, this is 1 plus 1/25. 1 plus 1/25 becomes 26 over 25 when I add both sides, or excuse me, that together. Notice what's going to happen. When you're solving this, you're going to have to multiply both sides by 25 over 26. And then add a constant. I claim this is the same thing as what we just found, because when you distribute 25 over 26 times this, you get 5 over 26 e to the 5x cosine x plus 1 over 26 e to the 5x sine x plus your constant of c. This was the exact same answer as we got here, although the two terms came in opposite. One of them was on the left, one of them was on the right. You can clearly see that these are equivalent though. 1 over 26 sine e to the 5x, 5 over 26 cosine e to the 5x plus a c. Whereas here we have 5 over 26 cosine e to the 5x plus 1 over 26 sine e to the 5x plus c. These are clearly the same thing, and therefore this shows you that it really didn't matter which piece you called your f prime and which piece you called your g to begin with, because they were both easy to either take a derivative of or an antiderivative of. Antiderivative going from f prime to f, derivative going from g to g prime. So there we go. Hopefully you got the right answer. Either way, you did this, you should get the correct answer.